So our third example for composites here, f of g of x might be better off written like so, because we're going to take g of x, this function, and we're going to plug it in to the function f, which means whatever's here is going to go here. And I like this problem because it throws this minus sign in here. So if I take this expression, g of x, and I plug it in for x, the format for f is to do 1 minus, okay? And then I have to plug this expression in for x. And we've talked about this in a lot of examples thus far where you have to put parentheses around this when you're plugging it in because we're subtracting this, which means we're subtracting every term. So we have negative 4x, minus x, and minus 5, right? We're almost distributing this negative sign to all of these terms. And we end up with negative 4x squared minus x, and then 1 minus 5, which is negative 4. So here's our function f of g of x. All right, now let's switch to g of f of x. Again, not going to be too kind here in terms of what this ends up looking like, okay? In fact, I'm going to probably need a lot of space. So let's say g of f of x. So I'm going to take f of x, which is this function, and I'm going to plug it in to g. And whatever gets plugged into g, and this is different from the previous two examples, has to go in two spaces, okay? It has to go in for both of those x's. So this g of f of x is, right, I've got the 4. Then I've got to put my input here. My input is f of x, which is 1 minus x squared, plus, then I've also got to put the f of x in this space. So I have to put the 1 minus x here. And then I have plus 5. Okay. We talked about in a previous example that I can't distribute this exponent. The best I can do is expand it like so, plus 1 minus x plus 5. And this becomes 4 times. When I FOIL all of this out, 1 times 1 is 1. 1 times negative x, negative x, negative x times 1, negative x times negative x is positive x squared. Plus, now I don't have anything here, I don't have anything here, I don't have anything here, so I don't need those parentheses. I'm going to drop them. I still need these parentheses because I got this 4. Now you can combine what's inside here, so we end up with 1 minus 2x plus x squared plus 1 minus x plus 5. And then we get our 4 distributed into this quantity, right? We had this 4 hanging out in front the whole time. I was always supposed to multiply 4 by this. It just took me a long time to get to here. So now I'm going to distribute that 4 in to all of these terms. And once I have this statement, I can combine all of my like terms together. So I end up with 4x squared. I've got a negative 8x minus x, that's negative 9x. And I've got a 4 plus 1 plus 5, which is positive 10. So here's my final composite function. This is our g of f of x. A lot of work goes into some of these when you have to expand those powers like that.